Hey, it's W5HRO. Well, it's been about a week or so, right? I thought I'd just give you another update. I finally went through and I tweaked all the cathode resistors and made some modifications. The cathode resistors on the first three tubes are 1.8 Ks now, and then I've reduced the 6N7 down to a 680. And that seems to all work correctly like it's supposed to. Uh, I reduced this down to 5 meg. I was looking for a 4.7, but I had a couple 10 meg, so I just paralleled them. A couple 10 meg, I think they were like quarter-watt resistors, small ones, so I paralleled them. It's just a microphone. It's not going to barely be. They don't have to dissipate any power, and what 5 mega ohms isn't going to do anything. So I've got that. I raised that up to 1.5. I'm thinking about making one more change. I think I might be able to reduce this 0.1 down to a 0.05 maybe. And I'm thinking about raising these guys up to 720. That would give me like a little over 1.4 meg on this one. So when I did that though, if I don't have the mic or the generator connected to the mic input, you know, with this audio gain pot up all the way so you get maximum gain, it does want to inject some noise now. But that's because, you know, I've made this thing a lot more sensitive. Like here, that's why they say you should only use, they say, you know, 1 meg from the grids of these things down the ground on the control grid. But, you know, 1.5 makes it a bit more sensitive, so that's what I wound up with, and I think I'm going to do the same thing over here. Now, what I'm getting ready to do now is I'm getting ready to power it up, and I'm going to start adjusting this AVC voltage to see exactly, you know, what it's going to do. So let's go ahead and power this up. I thought I'd already have this thing with the panel back on it and everything, but I realized too I need to work on the AVC. I've just been working on this kind of in my spare time. I haven't, it's been so hot, and it was cool out here this morning, so I've had my little AC unit on. It just kicked off. I did that because when it's on, it kicks on, you can see the actual output voltage of this plate supply drops down about 5 or 6 volts. It goes from like 351 down to like, you know, 345, 346, 347. It varies depending on how long this has been on. So let me run the audio gain up all the way. This is a 1 meg pot now. That's what I've had to go to. And that's because, see, if I turn the generator off, see, that cleans up. So $352, you know why that's doing that? Because the thing is just turned on and my plate supply, it's running a little hot. And this guy over here is off. Right now here in the shack, here in the shop, I don't really have much on the way of the AC. I've got these, well, I got the 2 big fluorescent lights on over here and one above me. And then these are really, these things, I finally had to put another set of these under the bench. My first set finally crapped out, and what's funny is when the one went out, 2 days later, the other one went out. So they're kind of like they have what do you call a unique, not a unique, but well, there's a word for it I'm thinking of, lifespan. And, you know, they last about the same lifespan each, like the same amount of hours, I think. So let me go ahead and I just wanted to not max this thing out all the way, turn it down 330 volts peak to peak, and let's start increasing the volt. This is going negative, so let's see what it does just by. And I started this thing at 0.1 volt. There's 0.8 volt. There's 1 volt, and I'm doing it there. Well, that might be because of the thing. Let me just start cranking this thing up to where I can see that voltage start to dip. And right now, the grid to cathode is like 5.1 or 5.2 volts. Because I figured out the 6SK7s, they want Is it 6? No, the 6N7 likes around 10 volts peak to peak on each grid is what it likes. So what I'm gonna have to do is let me back this thing down. I'm gonna have to shift over where I'm here. Now I can do it. There's a volt at a time. I'm going a hundredth of a volt at a time is like, I gotta really crank this thing up. I remember, because this thing's triode connected, and plus the what am I at now? I'm at 49 minus 49 volts. Now I wonder if my it's possible I'm clipped on top of solder. It may not be doing anything. I may not be making connection on that, because I think that should have already done something. There's minus 67 volts. It's not. So I need to double check my, let me turn this thing down. It's not doing near what it's supposed to. And I think it's because I'm not making connection on this. That's probably what it is. So let me set it here at 0 volts, like it's just not, like nothing's happening. I think this is my problem here. I think this connection, I don't have a good electrical connection on this. So let me, I wish I could see this better. I should have checked this before I started doing the video. Unless maybe I've got the resistors so big now that it's just these 620Ks are too big. Maybe if I didn't have the one going to ground, but if there's gonna be one with the AVC circuit in there, I was just trying to create a stable load for the output of the AVC. And maybe that could be an issue here. So I don't know if that's making, oh, you know why? I forgot there's an output on and off on this stupid supply. I didn't have the thing on. And see, what I've done is my AC unit here is kicked on, so my line voltage has dropped. So let me just kind of set this thing a little lower. Now, let's start doing this. It's still not doing anything. There's minus 40 volts. It's minus because I have it. Oh, you know what? I'm putting a positive. No, wait. No, that's right. I've got the positive side of the supply grounded. That's right. It's tied to the chassis. That should be okay. So why? Or do I need more voltage gain to stop it? Let me see. Why isn't that working? Wow, there's minus 51. That's not working. I got to figure out why the AVC's not working on this now. I need to put in my voltmeter. I'm going back to a 0 volts, but I've got the output's on now. So I guess I need to figure out what's going on here. So let me put my voltmeter on this, but you can see what I'm doing. Let me go ahead and I'm going to stop the video here, and if I figure it out, I'm going to restart it. Okay, I figured it out. It turned out that I forgot I hadn't used a supply except the first time that I got it. That's chassis ground. I need to be on this one. So it wasn't doing anything. I basically had the output shorted to chassis ground, but the supply is protected, so it's not going to hurt anything. So now, if I increase the voltage, there, now the AVC's doing its job. See that? Look at that. That's 23 volts. It says somewhere around 30. It's supposed to be cut off 30, but because I've got this thing triode connected, it's not going to do that. But that's minus 50 volts there. So that looks like it's going to work. Now I can go back here to there's 0 volts, so it's like nothing's there. So now let me turn the gain back up. Oh, look at that. Now let's go to turn the AVC. Look, it starts working right away. As soon as I go from 0, I mean, look at that. As soon as I go from 0 to even, there's 0 volts, there's -1 volts. Just, it goes down just from there. Look, it starts working right away. Look, and there's -8 volts. See, look. AVC's working. That should give me enough adjust. I can compress it good enough. Let me put it back at 0 volts. So now I know it's working pretty good. I'm going to back this thing down just a tad. Now see, there's way below 10 millivolts peak to peak there, and it's, you know, it's, this thing's pretty sensitive, so it's pretty good now. I'm happy with that. I'm just debating on, I think I probably could stand to have a tad bit more sensitivity. That's why I'm thinking of, I don't have 750Ks, that's not a standard value, but I have 720s. That would, like I said, that would make it like 1 point. Matter of fact, when I measured this one, it came out to be like 1.4 some odd meg because of the 1% tolerance. It was on the low side. And if I have two 720s, it equals 1.4 something. They're going to be the same on both anyway. So that would make this thing, so with a little bit less input here, it would have more output going to the control grid of this guy, just slightly. And if I knock this thing down to a 0.05, I'm going to put this back, because I went back on the SPICE simulator, and when I started raising these guys up, I could actually make that one a little smaller. And I want to see if it looks the same here as it will here, if I reduce this down to a 0.05 mic. If I do that, that would give me better isolation, because now with a 0.1, most frequencies are like almost dead short across this to this side. So it's going to be this in parallel with this resistor. So it's going to be less than 620, right? It's going to be like just below 400K. So what I'm saying is, the larger I can make these two guys, the better it's going to be. And I don't want any larger than like a 1.4 meg, because that's the DC path to ground. That's the grid leak on this. And I don't want anything larger than a 1.5. So at the most, 1.4, something like this one is, would be ideal. So, and like I mentioned, I reduced this one down to a 680 ohm. At one time I had a 500 ohm, but it was too low. Now with this configuration, it works great. And I just checked the plate supply. Even with this guy on, it was sitting at 150, 352 on the B+, so it's running a little hot, but after it stays on a while, if I leave this thing on and let it output for a long time, it'll, you know, it starts decreasing. I mean, I don't mean the output power, but the supply voltage. So if I leave it like this, and after a while it comes back up. So that's pretty good. Oh, one more thing. On this pot, I went to a 200, because when I ordered the 100K pot, I ordered some 200Ks too. I got these on Amazon. They were cheap. There's like a 2-pack of each one. They have knobs. They even have these things. And if I rebuild this thing ever over again, like I said, I may eventually do in another chassis. I'll just get another chassis, same size, re-drill it out to redo the layout. That knob would be on the top side of the chassis. It'd be on the other side. I mean this pot here. So I got a 200K, and one of the reasons for my delay is I just got these in the other day. I ordered a couple of the old Allen Bradley 2-watt 270Ks. So I got a 270K here and a 200K here for the 470 to match this side. That's what I've done. And I wanted the bigger resistor, these old Allen Bradleys, because those leads are so thick on the 2-watters that I was able to use that for support. But that pot doesn't move, because what I did was I found an old tube that was bad, and I busted the plate cap off of it, and I took some of that red RTV that I used on my Miratron amp to glue that insulation on the top of the lid underneath, you know, so it wouldn't arc or anything. And I just used some of that on the bottom of the pot and on to glue the plate cap to the bottom of the chassis. That thing's on there, it's glued, it's on there rock solid now. So that I did that, and then I hooked up the components. So with that and the reinforcement of the parts now, the thing is, it should be fine, it shouldn't break loose. So that's stable. I can just adjust it like I've done now before the lid goes, you know, the front panel goes across it. So anyway, that's kind of what I've done. And so let me finish working on this AVC circuit. Like I said, I'm glad I stopped to do this because I realized I had a problem using that that other two, what was it, that 6RS7 for the phase splitter. So what let me tell you what I've learned on this. Now, it's possible that if you did the 270 and do this 200K pot and did the same thing over here instead of doing the 20K and the 470, it's possible that might have worked the original way without adding this other tube. But it seems like what I've discovered, you want to do the phase split at a lower level, just like right after the speech amp, right? So you do the phase split here, which is what I've done, and I only need one of these for the AVC control, as you saw when I adjusted it, just both sides equally, because this is the same tube with the same amount of gain, triode connected. So I would imagine that the voltage gain is going to be both on both sides, so these things should track well, and that's what I was seeing. They seem to track really well, so I'm happy with that. So it works better like this. The only drawback is I do have a little bit too much overall voltage gain total going through all this by the time it gets to here. So, but I can make it work. Like I said, I got the AVC control, it should be fine. But if the problem is, the whole issue with this is that if I wasn't trying to drive a pair of 810s, I wouldn't have been shooting for 350 volts peak to peak output, because other tubes don't need that. The problem is 810s do, and you need it to stay somewhere close to 350, 340 peak to peak at full load, and that's the problem. That these things I've had to beef this thing up to really drive the piss out of those 810s is basically what it's boiled down to. So I've had to do excess. I've had to add extra tubes to cut, you know, them. If I was going to drive 811s or 813s or something, 803s or even 805s, I mean, I wouldn't need, I could just probably do the same thing. I could probably do this over here instead of doing, you know, adding this extra tube, and then 6SK7 could go right to the 6K7. But because of what I'm trying to do, I'm trying to get max voltage gain, and having it like push-pull here before it gets to the 6 and 7's even better. So it's working better, you know, that way. But I do have excess voltage gain, and there's ways to compensate for that. I just don't want to lose sensitivity at the lower input levels. So anyway, let me play around with the AVC circuit, and is there anything else I missed? I don't think there is. I just thought I'd do another video because I know it's been about a week or more. I thought, you know, everybody's sitting around, it's summertime, the HF bands suck. However, the past few days, like in the last week, the solar storm, one of them came back again. There was another geomagnetic storm, but when it started out, it made 17 meters start opening up, and even on 10 meters. Then the storm, it became majorly active, and it shut the bands down for 2 days. And the end of last week, it came up again. In the past couple days, even 17 meters has been open on and off. So even 10 a little bit. I've heard some activity. So the band's trying to open up, but it's like the end of July, and it's hotter than, you know, blue blazes. So that's all I've got for now, I guess. Like I said, I'll have plenty of time to bring the 810 rack out here, because all that's going to be a simple thing. It's not going through having to redesign things, trying to different configurations to get a circuit and everything to look normal like it's supposed to. I mean, this thing never in a million years did I ever get 40 volts peak to peak, 40 some volts peak to peak out of this thing with like that low of a load on it, 2.4K ohm load on the output of the transformer. This thing never did that. When it would do that, the current meter would drop and everything would just die, you know. So anyway, let me, I have a hunch though, when I'm trying to drive the 810s, this meter may actually still go backwards some. But I'm hoping it doesn't, but it might, because 810s require a lot of drive. So let me shut this thing down, and like I said, I'm going to play around with some feedback and some AVC circuitry I'm going to capacitor couple off here, go through a diode just to get a negative voltage. I don't really want an AC waveform. Feedback, that's different, but right now I just want to get a DC voltage that I can feed back in here to pull this thing down a little at higher end voice peaks. So that's all for now. Let me get back to working on this, and this is about a 12-minute video, so that's just about right. Happy July. Oh, by the way, happy video number 100. This is video number 100. 73s. What a milestone.